Okay, hello. Back to series sequence and progression. Now today we'll talk about tests for series to see if they are convergence or divergence. Now I will take you through the test series and then the graph sequence and the summation notation, then the infinite series and then convergence and divergence of series. First of all, if you look to these graphs here, we call them convergence. Why we call them convergence? Because if you can see here, all these came to same point. They are going to meet in one point. The same thing for here. They are going to meet here. They are going to meet here. So when they meet, I mean, they have a, let me say, a happy end, or they gather together. They come up together. We call them convergence. You can see that these rows going outside, they will not meet. The same thing for these. We call them divergence. So coming close or going out, what we call them convergence and divergence respectively. Now to start testing the series, first I would like to have some the terminology to talk about. Also to remind you that sequence, we have set of numbers related to each other, comma separate between them, and each item in this sequence, or each number in this sequence could call item. It's have a order or location, position, and it's have a value. Now the sequences we deal with, either we have what we call them finite series or sequence or progression, or infinite. Example, sequence number 1, as you can see here, these are the number 2, 4, 6, 8, 10. Their position, this is number position 1, position 2, position 3, position 4, position 5. So I have 5 position, I have 5 terms, I have 5 parameters. Okay. But here the same, but the difference is we have dot. When we say dot, it means go to infinity. For that, this one is finite and this one infinite series. Okay. It could have a general rule. As example, here we have a general rule which is 2 by n as example. Okay, an is the item and 2n is value. Okay, is value. N is its location, its position. This is n. Okay, sometimes they wrote it in function notation in this way as a function. You remember f of x? Okay, so we can write it in this way. Okay, now to test the series, as you let's start the idea from simple to more complicated. Have a look at this series here. We have series, its formula is written this way: an equal 5 minus n, and he asked me to write the first 6 items. So what I will do, I will substitute in this n for 1, 2, 3, 4, 5, 6. As you can see here, a1, a2, a3, a4, a5, 6. And then 5 is constant here. As you can see, it's the same, but I change only n. Do the math, use the calculator, you got the items, right? And another, let me say, series or formula here, as you can see here, 2 to power n, from also 1 to 6. So 2 to power 1, 2 to power 2, to power 3, to power 4, 5, 6. I do the math, I go the series. Still, until few, let me say, items into 6 or 10 is easy to do, but when we talk about millions items, really it will be difficult. So imagine how difficult it will be if we want to sum these items. Now he asked me also, as example here, write the first 6 terms of this is in function notation, f of n equal minus 3 to power n minus 1. So you can see here the first 6, so it means 1, 2, 3, 4, 5, 6. These are my items. And you see here minus 3 is the same. This minus 1 is the same. The only variable here is n. So n will be 1, 2, 3, 4, 5, 6. You need to do the math. always I advise my students to take care when they do the math. They know how to multiply, how to raise power, how to subtract and add, but when they have different terms, they may enter them to the calculator in wrong way and they got wrong answer. Make sure to work in steps, don't jump. Okay, here we are just substituting numbers. Now, sometime you may given the serious items and you may be asked to find the rule or the formula representing these items. As example here, but this is to be done by sense and experience, come up through the solution of many problems. So I advise you to back to the textbook, okay, and try to solve the exercises given there to get the experience. Okay, now if I look to this as example sequence, you can see the numerator is constant, which is 2, let me say. And if I come to the denominator, I need to link the numbers to see the pattern. 25 and 5, the difference is just squaring 5. And 25 and let me say, I mean here 25, we just square the 5. Here, okay, we just triple the 5. I mean, raise 5 to power 3. Here, it's like 5 to power 4. So I can't write it as 5 at the end, but rise to power n, because n will be 1. So 5 to power 1 is 5. 5 to power 2 is 25. 5 to power 3, 125. You see, by sense. So I can write the formula here is 2 over 5 to power n. Another formula. Here, have a look at this one. 3, 5, 7, 9. Definitely you will say, okay, it's look like the difference between them is 2. So it's like arithmetic sequence or arithmetic progression. Yes, you are right. You can write it in this way. A, which is a 3 now here, because the first item is a 3, plus n minus 1 by d, which is 2. So it will be 3 plus 2n minus 2. I entered, so multiply here and here. Now 2n plus 1, because 3 minus 2 is 1. But there is another way by looking to the pattern. Okay, have a look. We can say that the difference, yes, is 2. Okay, but 2 multiplied by n is 2. You need to add 1. 2 multiplied by 2 is 4. You need to add 1. 2 by 3 is 6. You need to add 1 to come up with 7. And so on. So I can write it from the pattern. Looking to the pattern, you can find the... Okay. Another, let me say, test. Another test. Another rule to find here 2, 6, 12, 20. We can write, you can look here to 2 and to 6 first. 2 is 1 by 2. 6 is 2 by 3. 12 is 3 by 4. Right? It's clear. So if I put it in, I mean, separate it here in this way: 1 by 2, 2 by 3, 3 by 4, 4 by 5. Okay? I can say 1, 2, 3, 4. It will continue. So this means it is n. And 2, 3, 4, 5, it means it started from n plus 1, because 1 plus 1, 2, 2 plus 1, 3, and so on. So we can write the formula here in this way. Definitely, we can put them as a table as we learned before. N is the position, first item, second item, third item, fourth item, and its value is 2, 6, and so on. Another example, describe the pattern. Write the next term and write a rule for the nth term of the sequence. He gave you the sequence here. Okay, forget about a minus, just look to the numbers. 1, 8, 8 is 2 to power 3, right? And 27 is a 3 to power 3. So can I say 64 is 4 to the power 3? Yes, I can. Oh, then I can put the minus either outside or inside. Okay, so we can write it in this way. Either put the minus outside and write here inside n rises to power 3, right? So 1 to power 3, 2 to power 3, 3 to power 3, it will give you the numbers here, the items in the sequence. Describe the pattern, write the next term, and write the rule for the nth term of the sequence. He gave you another sequence, 0, 2, 6. We can see that 2 coming from 1 by 2, 6 from 2 by 3, 12 as I mentioned in one of the previous examples. So why? Because of here 0, we can write it is 0 by n, okay, which gives me 1 by 0, 0, 2, okay, and the second one will be let me say 1 by, this is by 1, sorry, by 2, and the third one is 2 by 3, so and so on. So now this is 1, 2, 3, it is n, clear, right? But here 0, 1, 2, 3, 4, it's the same m but minus 1, because at the beginning 1 minus 1 will be 0. So I can write it in this way, n minus 1 by n. As I mentioned, by sense, you look to it and then try to derive the rule or the formula. Okay, we can plot them on Cartesian x and y. Okay, n represent the position, an is the term or the actual term. As example, here we have the first term is 3, the second term 6, third term 9, 12, and so we can write them in the first term its value is 3, second term 6, third term 9, and so on. We can plot them in XY, but it is not advised to connect them because I mean they are not, let me say, graph. Each one should be separate from the other. We can we want to see how they behave, these points. Now let's come to the summation. I mentioned for the summation we need to know sometimes the series up to a number, a position, specific position, or even to infinity, as I will show you later. So usually we use sigma for summation, right? As example, this series contain 2, 4, 6, 4, 8, 10. We have here 5 items. So I can write summation, you see, this Greek letter from 1 to 5. But I need to write the formula. The formula for this is clear, is 2n or 2i. By the way, we use I, N, K, it doesn't matter. Okay, so we use here 2n because 2 by 1, 2, 2 by 2, 4, 2, 3 by 2, 6, 4 by 2, 8. Okay. We can write it, we can read this expression is the sum from 1 to 5 of 2i. You see here, this is the summation notation. But what if the summation going to infinity? I cannot calculate up to infinity because infinity is not defined. It's infinite number. So here we need to use methods to find its value. Have a look here. Write series using summation notation. Okay. This is 4, 8, 12. As I mentioned before, we can write it as a 4i. Okay, because 4 by 1, 4 by 2, 4 by 3, and so on. And up to 100, okay, up to 100, 4 by 25 supposed to give 100, right? So this means that the summation is from 1 to 25 of 4i or 4n. This one, we can write it 1, 2, 3, 4, this is n. 2, 3, 4, 5, this is n plus 1, right? It's clear. So I wrote it here in this way. And if I want to find the summation to infinity, I will write sum from 1 to infinity. As you can see here. Okay. Another one here, another series, as you can see here, 25, 50. So it means 25 by 1, 25 by 2, 25 by 3. So it means 25n, 25 or I, okay, or k, whatever you call it. and summation up to 250. So 25, by how much I should multiply to come up with 200? Definitely we say 10. Okay, so it's summation from 1 into 10. Okay. Write the series using summation notation. 1, 2, 3, 4, 1 over 2, 2 over 3, 3 over 4. Then directly we'll say this is n and this is n plus 1. Okay. And since it's to up to infinity here, dots, it means going to infinity, so I need to write upper here of the summation notation into infinity. Sometimes it's started from specific number. As example, this here summation started from 5 up to 10. And if I want to calculate, I need to substitute in k here by 5, 6, 7, 8, 9, 10. Do the math and do the calculation to come up with the summation. But here it's just 5 or 6 items. Imagine you have millions, or you go into infinity. How it look like the calculation? So it will be difficult by take them item by item and do the calculation. I will show you a better way later on in our discussion. This is find the sum of the series. He gave you the series from 4 into 8. Okay? 5 items. 3 plus k squared. So again, I will substitute by k here bar 4, 5, 6, 7, 8, and I use the calculator to find the sum of this series. Another one also from 3 to 7. He gave me here k squared minus 1. So again, k to be substituted by 3 squared will be 9, 4 squared 16, 5 squared, and so on. Do the math. Use the calculator, you got the solution. Find the sum of this series, n. Okay. You will say, okay, from 1 to 6, n will be 1, 2, 3, and up to 6, so 21. Or, if we have formula, okay, formula from, talking from 1 to n, okay, from 1 to n, not to 6 now, from 1 to n, we have the formula here. Okay, so if I want to 6, I can directly substitute by n, which is 6, and do the math rather than I add them. By the way, here are only 6 items, but imagine you have million. You cannot work in this way, add them one by one. If you have a formula representing the sequence, then directly you substitute n by its final value, and then you got it, which is found to be 21. This is better than the simple calculation using one by one item, all of them. Okay. Now for sequence and series, don't forget sequence we separate between them by comma, and series we separate them by plus minus or plus or minus. Okay. But again, we have finite, as you can see here. These are finite sequence or finite series, or infinite, because we have dot here, as you can see here. Infinite sequence or infinite series. Now, infinite series is going to infinity from whatever n started, from 1 to infinity or whatever. We have many items. We cannot do the summation one by one item. Okay? As example here, this is called infinite series. Okay? From 1 to infinity, n over n plus 1. We have many items. We cannot do the calculation for all items. We need to look for a way. Now let's connect this discussion with convergence and divergence. Okay. Now have a look. If the infinite series has a sum or limit, we are going to infinity. So if it will have a value, then this series is convergent. But if it doesn't, do not have value, then we call it divergence. You got it? How we find this divergence or convergence? Now, if we have arithmetic, since no sum exists, it is divergent. We don't have sum for infinite here, series in arithmetic. So it have no sum. But in geometric, we have. You remember when we go to infinity? So if r, absolute value of r, greater than 1, then this is divergence. And if it is lower than 1 to have a value, then this is convergence. Okay? Because there is some. Now, another method is another classification part in this classification is the ratio test. By the way, there are many other methods, but I will focus on ratio test because it's a well-known one and simple, systematic, you can follow it. When the series is neither arithmetic or geometric, difficult to determine if it is convergence or divergence, so we use ratio test. Now, sum of the first item, it's the first item, but of 2, it means adding first and second, 3 adding first, second, and third, and so on. So this is called a sequence of partial sum because we're adding parts together. Okay? Now here, simple examples about arithmetic and geometric. He asked me to determine whether each arithmetic or geometric series is convergence or divergence. I will take them one by one. 1 over 8, 3 over 29. So it seems to be that there is no difference between them, but there is ratio, so it may be geometric. I divide this part over this part and the second part over the third over the second and so on. So I found that there is a ratio, common ratio, 6 over 5, it's found to be, which is greater than 1. So directly I will say this is divergence, according to the definition. Another one is this one. The difference between each items is the same, constant. So this is arithmetic series. So directly I will say this is divergence because there is no sum for infinite series, arithmetic series. Another example here, 65, 13, 2, and 3 over 5, and so on. So it seemed to be, when I divide them, I found the common ratio 1 over 5, which is lower than 1. Directly, I would say this is geometric and it is convergence because our absolute value of r is lower than. Now, let's come to the ratio test. Ratio test defined in this way. If you have limit of n approaching infinity for a of n plus 1 divided to a over 1 less than 1 or greater than 1 or equal to 1, as I will show you, it have a meaning. Now, this numerator is the same original series or sequence, but just rather than n, it will be for n plus 1, as I will show you. If the value is lower than 1, we call it convergence, absolutely convergence. If the value greater than 1, we call it divergence. But if the value equal 1, then this is inconclusive. It means the ratio test failed to determine if the sequence is convergence and divergence. I need to look for another method to specify convergence or divergence of the series. Okay. Now, as a review, just to remind you from the limits, you studied limits before. If we have limit n approaching infinity, here the numerator and here the denominator, we look to the highest power, okay, of the variable n here in the numerator and denominator. As example, in numerator, leading coefficient a, this is the highest, which is n to power 2, and for the denominator, higher is 2. We always look to the highest. It's 2, both of them, so that's fine. Then we will divide all items here by n square. Okay, when we divide, as example here, I will show you once and you can understand it. Okay, it means a n square over n square plus b n over n square plus c 1 over n square, because we are dividing, okay, over d n square over n square plus e 1 over n square. Now have a look, n square with n square 1, here 1, so as a solution here a d, okay, but for this one cancel 1 over n, and n infinity will go to 0, this go to 0, this go to 0, you see. So what is left? Okay, what is left is 1. Okay, what is left is now which means a over d. For the second function here, limit, you can see here the highest power is 2, the highest power is 3, then we will divide all item by n to power 3. Okay, so all these will go to 0. You can see, so the numerator will go to 0, then we have 0. See this here sequence or series. We want to see if it is convergence and divergence using the ratio term. Have a look. This is an. What about an plus 1? Every n will convert into n plus 1. Here n will convert to n plus 1. This is the first step. And the second step is to divide them and simplify. Have a look. I divide an plus 1 over an, and then I will start simplifying. You see, n plus 1 over n here, and this one to go over here, so n will be minus n, as you can see here, minus n. With n, what is left? 2 over 3, in this way. Now let's put them in the limit the ratio. Okay, 2 over 3, I will put it outside because constant. What is left? N plus 1 over n. Now can we divide? Because highest power is n. 1 over n, 1 over n, 1 over n. This one with this one 1, this one with this one 1, and this one will go to 0. 1 over 1 is 1. Okay, 1 by 2 over 3 is 2 over 3. 2 over 3 is lower than 1. Then we say this is convergence according to the definition. This is the second example. Okay, another example. This is n square over 2 to the power n. What about an plus 1? This n will be n plus 1, and this n will be n plus 1. Now I divide them. Now I can take this here out here and rotate it. It will be, you see, denominator become numerator and numerator become denominator, as you can see here. Now take this one here down. It will be 2 to power minus 2 minus n. Okay, just the power will change sign, the power sign. Minus and go with n. What is left? 2, as you can see here. And I take these two items, this item divided by this item, because they contain n, and 1 over 2, as I said, I put it outside. Now let me open this bracket. It will be square the first, which is n square, first by the second by 2, which is 2n, squaring the second, which will be 1. Now the highest power is n, so divide everything by n square, by n square, by n square, by n square. This go to 0, this go to 0, but this one go to 1, and this one 1. 1 over 1 1 by 1 over 2, it will give 1 over 2. You see here, 1 over 2. 1 over 2 is lower than 1, then I will say the series here is convergence. Another one, have a look at this one. It doesn't matter if become more complicated, the procedure is the same. You see here, this is an. So every n here, it will be n plus 1 plus 2, it will be 3, and here n plus 1, and here n plus 1 plus 1, it will be n plus 2. Okay, as you can see here. Now I divide them. Okay, this one to be taken over here, so we change their position. It means it will be n by n plus 1 over n plus 2, as you can see here. If there is way to cancel, yeah, there is. This one is cancelled with this one. You see? What is left? N by 3, n plus 3, and n plus 2 by n plus 2, n plus 2 square. Now we can either open this brackets and then look to the highest power. It will be n square. So when we divide by n square, it will take you to 1 at the end. Now the limit of the ratio is 1. What this tell me? This tell me that it is inconclusive. The test is failed to specify the convergence or divergence. Now use the ratio test to determine if the series is convergence or divergence. He gave you here the series, Okay, it seemed to be we need to find the formula. So 1, 2, 3, this is n. 2, 4, this can be written as 2 to power n. So I wrote the formula here first. Then every n to be changed into n plus 1. You see here n changed to n plus 1 square, n to power n equal to 2 to power n equal to 2 to power n plus 1. Then divide the ratio as you can see here. Okay, this one taken over and rotate as you can see here. See if you can these add together by taking them down. It will be 2 to power minus n, cancel minus n with n 1 over 2. Put it outside here 1 over 2 as you can see. Okay, no more here. And this one divided by n and by n and by n. You see here because the highest power, this one will give 1, 1. This is 0, 1 over 1, 1 by 1 over 2, 1 over 2. 1 over 2 is lower than 1, then I will say, okay, this is convergence according to the definition. Another example, use the ratio test to determine if the series is convergence or divergence. Again, I need to find the formula. I got the formula. Numerator is clear. It's 1, 2, 3, 4. It is n. And denominator is 2, 3, 4. So started from 2, not from 1. It means n plus 1. Now I write the an plus 1 to be n plus 1 and n plus 1 plus 1 n plus 2 as you can see. Then they divide the ratio. You can see the sequence, the series is changing, but the procedure is the same as I mentioned. Now divide the two formula, and this one taken over here, we will change their position as you can see here, and then simplify, multiply here this one by here and here, and this one by here and here. We got this formula. You see the highest power is n square, so divide all items by n square and simplify. You come up with 1. 1 according to the definition mean it is inconclusive. We couldn't specify the convergence or divergence of the series. Another example, here you can see 2, 3, 4, 5, it means n plus 1, and so on for the others, which is divided by 1, by 2, by 3, it means by n. Again, change this to get an plus 1, every n to be changed to be n plus 1, and simplify. Divide, we divided here as you can see, and taking. So as you can see here, we rotated this, we take it over and rotate it, and then we simplify. We up to here. You can see here the highest power is square, then they expect this will give 1, and 1 mean inconclusive. Another example, you see I'm changing the formula, but the idea is the same. You can see here 3, 4, 5, 6, then it means n plus 2, right? And here 2, 16, it means 2 to power 2 plus n. As I mentioned, you can find it by sense, or if it is given to you, it will be more easy. Okay, have a look here. n plus 1, every n to be changed into n plus 1. So I change them as you can see here and simplify. We got this value, divide it to get the ratio, and take the denominator up here and you change their position and try to simplify. See where is let me say similar items. As example here, this one and this one are similar, so I will take this down. It will be 2 to the power minus 2n, and then minus 2 and with 2 and it go, it will be 2 to the power 2, it will be 4. So 1 over 4 I will put it here. Okay, what is left here is the highest power is n, divided by n, it will give 1, because here over n over n over n over n, this one, it will be 1 by 1 over 4, which is lower than 1. This means that we have convergence series. Now test ratio, which is used for convergence and divergence. As I mentioned, we are going to find a of n plus 1 and then divide, simplify the ratio until you get the output, either 1 greater than 1, lower than 1. Each one of these outputs give a meaning. This is another example for this sequence. As you can see here, the formula un is 2n minus 1 over 2 to power n minus 1. And the formula of un plus 1, we change this n and this n into n plus 1 and simplify. We got this value. Divide them here. You can see. Simplify if there is way to simplify. As example here, this n, I will take it over here. It will be 2 to power minus n. Cancel with n, 2 to power minus 1, which means 1 over 2. I will put it outside. And this part divided by this part, as you can see here. Okay. Now, you see the highest power is n. So if I divide, it will be 1. Okay. So 1 by 1 over 2. You have 1 over 2. 1 over 2, it means lower than 1. This means that we have a convergence. Another example here. You have this series. Its formula is n over n plus 1. Then u of n plus 1, it means changing every n here to n plus 1. Now divide the ratio. You see, I'm following the procedure. The formula changed, but the procedure is the same. See if you can simplify. You open the brackets here, multiply here and multiply this one here and simplify. The highest power is n squared. You divide, you come up with 1. 1 mean it is inconclusive. I couldn't find a value. Now limiting value, to find, we can find the limiting value of any formula for a sequence. Okay, here as example here, by dividing by the highest power of n. Okay, as example here we have n, so we divide by n. This part will go to 0 when we substitute by infinity, and this is to 0. What is left? 5 over 2. Okay, when n go to infinity, we have 5 over 2. We have limits. And this one also, you can see the highest power is square, so we divide every item by n square. You can see here what is left. These are going to zeros. What is left is 2 over 5. There is limit. Another one here. The highest power is 3, as you can see here. We divide by n to power 3. This is go to 0, 0, 0. What is left? 1 over 2. When there is limit at infinity. It's been defined. We say it is convergence. When there is no limit, it is divergence. I will stop here. More discussion to be in the face-to-face session.